We're back with continuous quantitative data. Well, we learned about lower class limit, upper class limits. We learned about how to find the class width and how to determine the midpoint. Well, now we're going to go and say, okay, great. What do we do with that? Well, we want to make frequency tables. We want to take our data and be able to put it in certain different classes. Well, I shouldn't say that. Each data point can go into only one class. So we have to choose the number of classes desired, choose the class width, choose the class limits, count the number of measurements per class, and list the classes in frequency, the 5 that you see up there. Now, many of these are interrelated. So in other words, if I choose the class width, that's going to determine what the limits are. And it will also determine the number of classes that we desire. So those kind of go together. So here in this particular example we have of age, we had a sample of 3,373, and we took each of the data points that were in that sample, and each of them went into one of these 5 categories. So someone that was age 45, well, they would go into this category right here. A person that was age 50 or 55 would go into this category right there. So what we need, good practices for constructing these tables, histograms and tables, is there should be no overlap. In other words, a data point goes into one and only one class. It can't go into 2. There shouldn't be any gaps. If there were gaps, then maybe our data point won't find a place to go, so we don't want to have gaps. And we want to cover the range of the data. All of those mean that every data point in our sample has a place to go. Now, another good practice is to make sure that the widths, the class widths, are all the same except for those open-ended classes, the extremely low or extremely high ends of our data. We should make sure that our class lower limits are reasonable and the widths are reasonable. And typically we like to have between 5 and 20 classes. Anything less than 5, it tends to bunch up the data, so you don't get a really good analysis of the data. And if we have too many, the data is so spread out, again, not a good analysis is going to happen because we can't detect any patterns going on. So too few and too many classes, not a good thing. So let's take a look at some continuous data. This particular data goes from 0 to 2, but not including 2, when we look at the classes, 2 to 4, not including 4, 12 to 14, not including 14, 14 to 15, but not, 14 to 16, but not including 16. So I hope I did the other one right. It's 12 to 14, not including 14. What you see here is that we have these in units, digits, and we're saying this first class contains all the data between 0 and 2, but not including 2. So 1.99 or 1.99999 would be in this first class. But as soon as I hit 2, I'm into the next class. So that brings us how histograms are made, or when you're looking at them, what they mean. These numbers 0, 2, 4, 6, 8, 10, 12, 14, 16, they are the lower class limits of the classes. And we call them, we have them at the cut points, or the beginning of, here's our first bar, the cut point 0, and there's a cut point 2. Those, and again, the cut points are always the lower class limit. So when we construct our histograms, constructing the frequency or relative frequency histograms, we need our frequency or relative frequency table to put our data in and to know how to construct the histogram. So we want to place our variable on the horizontal axis, and then on this side, on the vertical, we'll know whether it's frequency or relative frequency. And we want to make sure that those are clearly labeled. And we want to make sure that our lower class limits are clearly labeled on our graph. And when there is units, we want to make sure that we put units here to see. So the height of each of these rectangles is either going to be proportional to the frequency or relative frequency of that particular class. The grouping of those continuous variables values. So in the construction, we want to make sure we plot and label only the lower class limits, like I showed you at the cut points. Provide a descriptive title, and in our class, here's our generic title, distribution of. It's going to be the name of the variable for, and you describe the item. Label that horizontal axis. We've got to know what the name of the variable is, and if there are units, you must include those units. Very important for somebody to read, because remember, they're going to look at this graph, and your goal is to make a graph where they don't have to ask you very many questions, if any questions at all. A really good graph is done so that very few questions are asked. So, looking at this particular example, alcohol-related traffic fatalities. The following frequency histogram represents the number of alcohol-related traffic fatalities by state in 2003, according to data obtained from the National Highway Traffic Safety Administration. So as you can see, we have good labels here, number of fatalities by state, and this is a frequency histogram. These are alcohol-related traffic fatalities. So we would say in our class, we'd say distribution of alcohol-related traffic fatalities by state. That would be the title that we would use in our class. So first, determine the class width. How do we do that? Well, remember, to determine the class width, our convention is to take the lower class limits and subtract them. So that would mean take 200 and 0 and subtract them. So class width is a 200. I didn't have to take those two. I could have taken 400 and 600, but still you subtract those two, you get 200. So our class width is 200. And now we can identify the classes 0 to 200, but not including 200. So you could say 0 to 199, because these are fatalities, either you're dead or alive, so it's pretty discrete there. 200 to 399, 400 to 599. But again, another way you could say it is 400 to 600, not including 600, if this were truly continuous data. So they'd ask us, which class has the highest frequency? Well, that one just means which one has the highest bar. Well, we would say the class that has the highest bar is between 0 and 200 fatalities. 20 states had between 0 and 200 fatalities. We're going to get into what Minitab cut point command would be used to generate this histogram later. But what we're going to do is just kind of continue on here with some of the questions without Minitab, and we'll come back to the Minitab question in just a moment in our next segment where we work with actually creating these histograms. So approximately how many states had between 200 and 400 fatalities, not including 400? So you'd say it would be this one right here, and we would say 15 states had between 200 and 400 traffic fatalities, not including 400. Approximately what percent of states had less than 200? Well, less than 200, there's 20 out of the 50 states, and that's how you would determine the percent. You do 20 divided by 50, or 40%.